Kitten, hey, stop. All right. Hi, guys. So I'm doing a redo video 3.3. I had absolutely no idea that all of my old videos were going to turn out the way they did. I'm trying to get through, and I've tried re-recording them a couple of different times, and they all turned out even worse. So I'm thinking I may have fixed whatever needed to be fixed, and I'll see if I'm better. So I guess if you see this video, it's better than at least the one that's posted currently. So we're talking about 3.3 properties of logs. The first one is going to be the change of base to base B. B is going to be any number that we want to change the base to. We do this for many different reasons. The first one's going to be simplification purposes. So maybe we need to put this in a different base in order to use a property to simplify. It's also for ease of calculator work. If you have a calculator that you're only able to use base 10 in, you would have to do change of base property in order to put something in your calculator. Many different reasons to use it, but this is how you use it. So let's say this was my original log. A was C was the original number I was taking that log of. If my new base is B, it's going to be log B, log base B. C goes on top, A goes on bottom. So let's say that I have the example log base 4 of 25, and I want to change to base 10. Okay, what's going to happen is my new base is log 10 over log 10. 25 goes on top, and base of 4 goes in my denominator. Again, I would just be able to actually plug this into my calculator. So since log base 10 is our original log, we can go ahead and use this actual log button. So we're going to have log of 25 all divided by log base 10 of 4. This equals 2.32. I also want to reiterate that this is true for if we want to change to base E. Say we want to get out of normal log and we want to change to natural log. So let's take this exact same, let's do log actually base 2 of 5 and say I want to change to base E. Again, log base E over log base E. 5 goes on top, 2 goes on bottom. Now, by now, hopefully you're recognizing log base E is actually natural log. So we'll have natural log of 5 over natural log of 2. In my calculator, this button's going to be found right here. So I will take natural log of 5 divided by natural log of 2. And that is 2.32. All right. Very good. So let's move on to the actual properties. So we have 3 different properties. The first one is called the product property. The second is the quotient property. Third is power property. All right, with the product property, what we're saying here is if I began by taking, well, I'm actually going to go down here. If I had log of base A of U times V, I'm going to go ahead and be able to separate this out. I can change this to log base A of U plus log base A of V. Anything that's true for log is true for natural log. So if I'm taking natural log of U times V, I can separate this through addition, natural log of U plus natural log of V. All right, same thing for quotient property. This is if we're taking log base A of U divided by B. Since I can separate multiplication through addition, that means I'm going to be able to separate division through subtraction. So I can take log base a of u minus log base a of v. Again, if it's true for log, it's true for natural log. So we can separate this natural log of u minus the natural log of v. The power property is going to allow us to manipulate exponents. Let's say I have log base u to the n power. What happens is exponents are able to be thrown out in front. So this would be n times log of u. All right. Again, true for natural log of u to the n equals n natural log u. What I want to be really careful in explaining is that these aren't a one-way property. It's not if I have this, I can get to here. It's both sides of the equal sign work. So let's say you start with two things being added together with the same base. You can change those into multiplication. You can change the subtraction into division. You can put numbers out in front, up in the exponents. So both of these properties work both ways, and we're going to see how that works through expanding and condensing some functions. So when asked to expand, the following expression. This is the natural log of the square root, 3x minus 5 over 7. So one thing you should know by now is that we can rewrite rational or radicals by rational exponents. So that's what I'm going to do first. This is the natural log of 3x minus 5 to a certain power. So whatever number is technically out in front. When it's a square root, there's no number written. I wrote it here to help you. We can assume that's a 2, though. And then whatever exponent's up top, it's generally just going to be a 1, because this is all just to the first power. You take the exponent over what your radical is as the rational exponent. So this is going to be 3x minus 5 to the 1/2. So if I'm expanding this, I'm going to deal with my exponents last. So I first say, well, if I have both natural logs of this division, I'm going to say it's a natural log of the top minus natural log of my denominator. Okay. Last step here would be throwing exponents out in front. So I'm going to have 1/2 to the natural log 3x minus 5 minus natural log of 7. I ask myself now, is there any way I can get more simplified or more expanded out? At this point, I have no other properties that I could apply. So that's as the most expanded that I could get. What about condensing then? Expanding is drawing out, so condensing is going to be making smaller. We want to condense 1/2 log base 10 of x plus 3 log base 10 of x plus 1. So when we condense, exponents are last. When we expand, exponents are last. When we condense, exponents are first. So any numbers out in front need to be thrown back up on top, meaning I have log base 10 of x to the 1/2 plus log base 10 of x plus 1 to the 3rd. This I cannot simplify at all. I can't do anything with that, but I know when I have rational exponents, what that means is they're actually a radical. So log base 10 of the square root of x to the first power. I know it's a square root because 2 is what's on my denominator of my exponent. 2 would technically be out in front here. 1 goes on my numerator then, or my numerator 1 is my exponent to this. So again, plus log base 10 of x plus 1 to the third. So now I know when I'm condensing, I can get rid of 1 log. So I can change this addition into multiplication, making it log base 10 of the square root of x times x plus 1 quantity cubed. And that would be as condensed as I could possibly get it because I can't go any further from there. All right, these are just 2 examples of the many different ways that we condense and expand functions. You're going to see lots of different versions of this on a worksheet for homework instead of doing problems out of the book. Worksheet's going to be much longer, but we're also going to take plenty of class time to do so. All right, hopefully this video worked better than the last. That's my hands squeaking, by the way. I see I keep making it. It's my hand squeaking. I'm sorry. Okay. That is it.